All right, as you see, I have the longest title in the world. I'm not going to repeat it. She said it wonderfully. So just before we begin, just some safety instructions. As you know, we are in the pizza room. So as you've seen yesterday, please do not bring this into the room. Strictly forbidden. Italians will kill you. So just some safety instructions I was supposed to tell you. All right, so just a few words about me. As was mentioned, my name is Yossi, and I've been using Python professionally for something like 12 years now. Sounds like a lifetime. Just to give some perspective, at the time I was using Python 2.6, some of you even heard about it. And Python 3 was like the cool kid in the block. It had like parentheses for the print statement, very exciting stuff. It's been a while. Today I work for Smitten. We are a startup from Iceland, and we are building a dating app. Yes, exactly. Very exciting. We are so excited to be a sponsor of this conference, as you can see. And yeah, very like way down below at the list of those who paid very little to become a sponsor. But that's aside. And we are obviously using Python for our backend, which is the most fun language to build the most fun dating app, of course. All right, so just before we go through what's going on, just a quick agenda. I'm going to be talking about what are operations script, which is a term that I coined, so it's definitely needs to be explained. And then we're going to go through how Python can be used to make them better, because Python is awesome. And then just go through a bunch of examples to prove my point and make me sound smart. All right, so just some definitions. What's an operation script from my point of view? So I would say an operation script is just a real script, like in the old days, that performs some kind of a routine operation. And by routine, I mean something that you write once and you use it many times, often by many people. And I gave a few examples here. It can be deploying your code from a server to a different server, or configuring a database, establishing connection to some entity, something that is kind of like annoying but has to be done. And often these problems revolve around using some kind of a third-party tool. I listed some here, like AWS or Terraform, Docker, all kinds of CLIs out there. And often it can be just using some binary that you wrote, maybe some C library that you compiled, and you just have to use it in a script. So all those things, I call them operation scripts. And naturally, since we're working with a bunch of binaries, like all these tools, the most natural thing to do is to write a bash script or a ZSH script for the Mac users of you. And yeah, or just any shell scripting language. And I like to think of them, like this is a lot of fancy words. I like to think of those scripts as the things that glues stuff together, right? You have your great business logic, your web server, your system, everything nice and fancy, tests, linters, formatters. But then there's like the last 2% of the work, which is to actually get that stuff into production. And that's where you have this little script written by someone who quit 10 years ago. Nobody knows what's happening. And like this is that, and it's just there. And it's like nobody talks about it. It's just like, yes, the magician wrote it. Don't touch it. It's just there. So like, just let's look at a few examples. So let's start with like a nice script, like a nice bash script. Here's one. I hope the code is visible. You can see this is a script. It has even the shebang line. And we're doing standard stuff like loops. We're defining a variable. And in this case, we're calling the AWS executable. It doesn't really matter what it does. We have two commands sequentially, passing some information. Not the best, not the most terrible. I think it's fine. But then, you know, this is not real life. Real life are evil scripts. And evil scripts are scripts that are like wearing a mask, right? It looks fine. It looks like just like, you know, 6 lines of happiness. But then when you look deep into what's happening, you're like, double semicolon, must be a mistake. Oh, no. It's supposed to be there. And then you're like, okay, log debug is probably a function. Where's the brackets? Or maybe there's no brackets. But wait, the if statement has double brackets. What does that mean? And you look at these things and you're like, what? Like, just what's going on? And you know, you look at the if statement and it's like strings compared to like variables, dollars, like what's happening? And you're just thinking to yourself, why can't I have a normal if statement? Like, what is going on? And at least that's my experience. And maybe everyone here is a bash professional. I find myself in this position very often. So maybe like now is a good time to make a short poll. How many of you have written or used a bash script in their life? Okay. How many of you have seen an evil script in their life? Good. That's good. Because if not, I would just go home and say like, all right. So this is good news because okay, I did the poll. So these are operation scripts, or at least how I perceive them. And in the real world, I think that they don't get the love that they deserve, right? These scripts tend to look like this, even though they are critical, right? And critical not in the sense that they are running all the time or they are like business logic, but without them, we can't do what we're supposed to do, right? We can have the best code out there. If we can't deploy it, or if we can't configure the database, or if we can't connect somewhere, it's just not there. It's just like, can you let him in? That's the, yeah, thank you, sorry. Yes, we came all the way from Iceland, didn't sleep a lot. Sorry. So yeah, so like this code is like critical, but like not in the classic sense of like it's like running in production, but it needs to work. And I have just shown you a few of the downsides of using Bash or any other scripting language, like yeah, just error handling, code inconsistency, and let's not forget the scumbag Bash that can fail and still return a success return code. Remember this guy, he's gonna come back later in the slide. Okay, so this is all nice. I've been talking shit about something else. Let's be a bit more optimistic. So a few years ago, I joined a project that was written in Erlang, a completely different programming language. It was great. We had all kinds of modern tooling, but the scripts were written in Bash. And guess who got the responsibility of maintaining all of them? Yes, Yossi, if in case you didn't notice. That was me. And I got the responsibility of maintaining all those scripts, and there were like dozens of them used by a lot of teams, and they were all in the state of like, don't touch it, it works. Like it's just, the dollars, that's the but also they needed to be changed. So at first I was just trying to learn Bash and understand what was going on, but I was not smart enough. So I decided to try Python, which was a language that I was just using for personal projects at the time. I decided to try out using Python for this purpose, and I set out on a quest. And my quest was to keep using the Bash for the actual raw CLI commands that I need to do, but try and do everything else in Python, because just like the most basic things, like conditions and loops, we just saw how a condition looks like. Just the most basic things are so much nicer in Python. Like the language just feels natural. Just yeah, I wrote here like strings, just like manipulating strings or handling files and all those things. And I want it to be good. Like I want a solution that is like simple to use in the sense that it just works. I don't have to think about weird things. And the code has to be maintainable, of course, unlike the Bash code. And obviously, I want to kind of leverage all the safety that Python provides. So like types, error handling, exceptions, signals, all those things. They're just so much more nice in Python. So I was going on my quest. I was trying out a few solutions in Python. There's like 3 or 4 different just built-in Python solutions. And after a few trying, I ended up with something like this. I found out there's a module called subprocess, which does pretty much what you would expect. It provides an API to run a command and interact with the output. So the result is pretty simple. We have here the run command, which just accepts a bash command or just any kind of shell command. I end up calling subprocess popen, communicate, some kind of API with some magic arguments, and I get the result back. I get the output and the error output, which are just 2 output streams of a bash command, and the return code, which we saw earlier means nothing. It's just a number just randomly sent by a command, and good luck. So this was nice, and I wrote this pattern, and I started converting all our bash scripts at the time to use this kind of a thing. And it was very nice. I was finally able to have normal if statements and for loops and just have bash where it needs to be. And as I went, I was converting more and more scripts, and the requirements grew, and I was kind of learning what I wanted. And I figured that just using this directly was not enough. I needed something better. I wanted something super simple. I wanted you to have just this one function that I can call, in this case just run, and it just kind of handles all those annoying things that we do in scripts, like moving to a different directory, or setting a different environment, or piping in from between 2 scripts. And I wanted it to be extremely safe. I wanted something that is typed, that handles errors, handles signals, timeouts, all kinds of things that can go wrong. Because when I write my deployment script, I don't want to think about, oh, what's the return code? I just want to write the business logic that I care about, just like every other part of the code, and just let kind of someone else take care of the rest. And the subprocess module we just saw is what Python came out for this problem. But it had too many API calls. It's still too low level. It has like 4 or 5 different API calls depending on exactly what you want to do. So I figured I have to create a wrapper around it, which we did, but I wanted something fancier. So I created a Spix library. Spix was my attempt at shell Python execution. Not the best, but it's fine. It's a short word, and it was free on PyPy. So I just ended up creating this library, which is just a slightly fancier version of the same function. And this library exports the one and only function run, which looks like this. It still has just one mandatory argument, which is the string, the command that you're passing, and a bunch of configuration options that were useful for me. For example, logging the command or the output if I want to. I want automatic verification of the return code if I want to, and so on and so forth. And everything is obviously typed. And even the result, in this case an object, is a typed object that I can then Pythonically interact with. So this was my dream, like create this API that is just one function, returns one object, very simple, and kind of handles most of the boilerplate for me. And like, you know, this comment comes at the expense of like 300 lines of code, because so many things can go wrong, like signals, errors, timeouts, output issues, all kinds of exceptions, keyboard interrupts. So this is what we have today. This is the library. It's very nice, and I'm just kind of tapping my own shoulder. But let's see it in action. So now we're going to see a few examples of real scripts from Smitten. So if you're building a dating app, you can copy that. No, you can't. It's not really interesting. The first example is going to be a very simple script where our requirements are just to kind of prepare a script for running by making sure that the AWS CLI is just some kind of binary, that it exists, that it has the right version on the system we're running, and we also want to verify that some environment variables, these two, probably some of you have seen them, that they exist. This is a classic requirement for a bash script, kind of just like verify AWS, but we're not in a bash conference, aren't we? So this is how it looks like. This is the code as it is on Smitten. You can see that we just have a function, like a Pythonic function, that does all these things, and it just does the things we said a second ago. You can see that we're running the AWS -- version command, which is a bash command. You can't escape that. But all the stuff around it, checking the return code, checking the output, is done in Python. And we can do, and even though this is much more code, this is very explicit. And we can do something like starts with, which I don't even want to think about how that looks in bash. It's just, oof. Like this is very, very, very nice. Everything is obviously typed. And the second part of the environment variables, we don't even need bash for that. We can do it purely in Python, which is, in my opinion, better when possible. So this is just an example of how we take a very simple requirement for a bash script and do it in Python. All right, let's look at a slightly more complex example. So in this case, we're using the Terraform binary, which is also some kind of a CLI tool. And what we want to do is call two commands, Terraform init and then Terraform plan. And it doesn't really matter what they do, but we just want to call them one after the other. And we also want to do so in a pre-calculated or pre-provided directory and environment variable setup. So like we have some other script that does a bunch of other things, and as part, it does these two things as well. Again, looks like a classic bash script, just run the two commands and all be good. So you would think that something like this is a good start, right? We have, again, a Python function that accepts the directory and the environment variables, which are typed, and some of you have been in the type talks, and you know the types are great. So we just run the two commands, like so, and we can provide the directory and environment variables to the function, which means that we don't even have to do stuff like cd directory or preset the variable in the beginning. Like we're doing everything in Python, which is just better in my opinion. But this is a good start, and this is how we would like start with a script on Smitten. But oh no, who's back? The script fails monster. It turns out the Terraform plan returns 0 all the time. It doesn't really care about what you're doing. It can fail, it can crash, it can timeout, it will still return 0. So that's where our utility tooling come to play. So yeah, so the Terraform plan command will always return 0, and sometimes just randomly it gives out this string error, text file busy, still returning 0, of course. And in that case, we want to retry. So we start with a simple script, but then as we test it out and we want to kind of make it more robust, we want to handle some edge cases. So we end up with something a bit more complex. We still run the terraform plan command with a special detail exit code argument that you can find in the secret documentation that will then give you the real return code. And then we do all kinds of like result handling. Like for example, if the return code is 0 and successful, we then quit. But if it's text file busy in the output, then we like, in this case, we sleep, we could error, we could do something, and in the case of another exception, we just quit. But the nice thing is that all of this, like look how many lines of code there are here for a single bash command. And it just shows you like how many things could go wrong, and handling them in Python is just nicer, and you can add comments and all kinds of things. And obviously this increases the volume of your script by a lot, but it's safe, and it will do what you want to do, and if it doesn't, you get an indicative error, and not just like return code -1, and that's it. So this is a bit nicer, and this is how we do the actual run in our system, and this is the full script altogether. And yeah, just the important thing to see is that the bash command, each one of them has to be treated with like delicacy. Each one deserves its own block of code and has to be treated like a cat, like a king. Like, you have to be super careful, because if it if it just moves one thing, it's just gonna crash. Okay, let's see another example. So this one is a bit of a long code. Let's see that. I hope that it works. So this is the real release script of the Smitten project. And this is just a list of things we need to do. We want to verify the AWS version. We want to clone the repository, run some script, call GitHub API, call Git API, or just in other words, a bunch of CLIs that we have to call. And what's the best place to run a few bash commands? Python. So let's see if it's bigger. Yes. So this is how the release script looks on our end. And you can see again that the first thing to notice is that each bash command is treated like gets the respect it deserves. It has its own block, and each one is handled separately because each one has a specific requirements to make it work well. And you can see that, for example, sometimes we want to like run a command and just do nothing with it, just change a directory. In another case, we want to compare the output and do some logic. Here, we want to set up a specific environment variable in the execution. This is my favorite. Here we're running a bash command, and then we're doing some magic with the output, and this is disgusting, but it's going to be even more disgusting in bash. So it's like, choose your battles. And again, the important thing to see here is that we get to give the emphasis for each command, to give it like the respect it deserves, have the focus on each command separately, and we can just use Python. For example, we want to do all of this inside a temporary directory. We have the Python temp file module for that. Like, this is just pure Python. We use the AWS CLI function from before. We don't even care that it does CLI stuff behind the scenes. Like, the idea is to just migrate, at least the plan was, to migrate as much as we can of this logic into Python so that we can really have the bare commands that we need, and that just gives us safety. And now all these scripts are running in some CI machine remotely on some cloud's instance. And if they fail, I want to get an indicative error and not just return code -1 or something strange like that. So it's nice to have Python running, just like have it get a Python exception with a stack trace. And you can, of course, use stuff like breakpoints to debug it and so on and so forth. So this is all nice. And this is just how we do scripts at Smitten. And our scripts are safe. And I find this simple. I might be wrong. So just kind of thoughts about where this is going, right? So this is all very nice, and of course I am in love with the library that I wrote, but it doesn't mean that it's the best library out there, and there's quite a few alternative solutions. I mentioned some of them here, and each of these projects is essentially the same story. Some guy was trying to run bash, and they were like, what's going on? And they just created a library, and each of them has a slightly different approach. Some of them were focusing on running stuff remotely. Some of them are looking into like just letting you import into Python commands, like all kinds of things. But everyone shared the same idea of don't use bash directly, don't use subprocess directly. We live in a modern world, use high-level tooling. And this is what I hope for. Like, I hope that in this talk I can convince you at least a bit that there's tools out there to do those things, and operation scripts deserve some more respect because we all have them. Everyone's talking about AI, AGI, and data frames, but half the internet runs on bash scripts. So it's just, I think they're just using some high-level library makes them simpler to work with and more enjoyable. I think I'm enjoying doing that kind of work. But I encourage you to check out those libraries if you have those scripts, even if you don't want to admit so. And I think that would be it for me. Good.
Thank you so much, Yossi. And we have a few other questions here, but also if you have questions, you can just raise your hand. And one of the questions is it possible to pipe ciphex command one after the other?
Is it possible to pipe? I don't know who asked this, but if you mean the pipe operator, like do for example, the pipe operator. So this is a great question, and I didn't prepare a slide for it, but I do have, where I have this. Sorry, I'll go back to the slide. At first, I was a bit against it, because I said if you're piping between two commands, might as well run the first command safely, make sure it succeeded, and then use the second one, because right, that's the whole idea. Because what if you pipe commands and the first one like does some random stuff, like God knows what gets piped. But sometimes you still want to do this, and I added this configuration option here, Unix raw, which just lets you pass basically like a raw bash command with pipes and what's it called, like the triangle operator and so on. It depends on the use case, and yeah, so it really depends on what you want to do. Everything should be possible, and the library, or just like the script, should serve you, not you it. So yeah, it's possible, but sometimes I would not recommend it.
Thank you. And we have another question. How can these CLI functions be tested?
Okay. Great question, because I mentioned earlier that we want to have like the tests and linters and formatters. So it's a good question, and it is still a difficult part of the system to test because you are calling some third-party API. And if I think about it, we don't test that too much. We mostly rely on the library and just the safety it provides to test for the basic stuff, like that the return codes match, that there's no unexpected outputs, that nothing times out, signals out. But if you really want to test it, I would guess you would want to use some kind of a mocking. Just have a mock to the library, just like you would test any kind of third-party API. Yeah, I would say so.
Do you have any question? I can bring the mic to you. Okay.
Use this one.
Hello, hello. Hello, hello. So I wanted to know, because there's a lot of converters now online, for example, JSON to YAML, YAML to JSON, JSON to JSON schema, etc. And what you showed us is the end result of what you had to do yourself to convert the existing bash into Python. Do you know, or is your tool providing a way to convert directly from bash to Python to help us doing the conversion?
Do you mean if you have a bash script, like convert it to using this?
Yeah.
There is no automation. You're more than welcome to create some. Usually I would say the process for me is you start with some bash script that's already there, and you just, I usually just rewrite it or rewrite parts of it into Python. No, I don't think there's any kind of automation. I think that would be just too hard because of all the magic that people do in bash scripts. But, AI, ChatGPT, should be possible. Good question, thank you.
Any other questions? Okay, we have one. Okay. Yes.
I wrote a question that's there, but I might as well just ask it. If, let's say, I adopt your library and I'm starting to write scripts with Python, and I've installed your package, when would I reach out to install like a typed Python package versus calling out to a shell script? How kind of like, can you provide some guidance as to when you might install a package if you already have an environment?
Sorry, I'm not sure I understand. Can you say again?
Yeah, so like at this point when the script is running, I've got the Python environment set up that has your package installed in it. Okay. When would I install some other client, for example, to call it to GitHub, versus use the CLI?
Okay. Great question. And as I mentioned, okay, I think I get it now. So many of the tools that I pointed out here, like for example, the GitHub API or AWS, they have their own Python libraries that you can use. Probably some of you use like Boto or something like that. Great question. And the answer is just like everything, it depends. I would say that when you take a bash script and convert it, it's easier to start with this because you get to keep the code as is and just kind of get like the annoying bits into Python. And most of the time, these scripts, as I said, they're not part of like the big picture. It's just like this one script, and there is some overhead to using like a library, right? It has its own quirks. So I would say it really depends. I would say start with simple. Start with like something like this, one of the libraries that do this. And if you have like a very long script, or you're doing a lot of calls to the same like a third party, then I would use the CLI tool. So I would like, yeah, something like that.
Any other question? Okay, we have one online. What is the difference in Cyphax? So it is reasonable to create another library which solves the same issues.
What is the difference?
What is different in Cyphax? So it is reasonable to create another library which solves the same issues.
You mean what is the difference between this library and the others?
Yes.
Okay, I think that was the meaning. So as I said, a bunch of smart people created their own libraries to serve their own needs. And I think, again, if you're considering using one of them, you spend the 20 minutes to check out the differences. I would say each one was created to serve a different purpose. And in my case, my goal was to make stuff work. I wanted it to be safe. I wanted it to be consistent. So I was focusing on the signal handling, error handling, logging, outputs, and so on. I know the other libraries are some of them are more focused on just letting you write it faster. So you can just kind of take the bash command and just import it from Python and do something else. Some of them focus on running stuff remotely, if that's the thing you're doing mostly, if you're like deploying to Kubernetes to like a bunch of servers. So I would say, yeah, just read the docs of each of one. They're usually pretty short, and check out which one serves the needs for you mostly.
Any other question? Okay, we have one online. What does Cyphax? How does Cyphax compare with Typer? When should we use Cyphax over Typer?
Typer.
Yeah.
Good question. Typer is just for someone who doesn't know, Typer is the library created by Tiangolo from FastAPI, I think. It's yeah, I think it's more like Typer is more about how to make your Python script a CLI tool. So if I have a script that like what used to be stuff like argparse or just going to sys.argv, so Typer is more about just taking your Python code and exposing it into the shell. In this case, we're doing the opposite. We have a shell command that we want to run in Python. You could probably use both together. You could have a shell running inside a Python script, which is then exposed back to the shell. And then call yourself and just like enter in a loop of pain.
Thank you. And we have another questions online. Does Cyphax define custom errors to be used in try and exec?
Yes. I probably didn't mention them, but yeah, we have, obviously, because I want to be able to handle those exceptions. And yeah, I'm not going to go deep, but basically the different types of issues that can occur during the execution, like timeout, signals, inconsistent return code, they have exceptions. Yeah, I should have probably mentioned that in the talk. We have like a top-level exception class, and it has a few ones below, and you can obviously catch that and handle that gracefully. Good, great question. I definitely should have mentioned that.
Any questions from the room? Okay, we have one online too. Yeah, you have.
It's just me writing to myself.
So, what would be better, implementing bash commands in Python like Cyphax, or use a Python API when available?
Okay, so it's just a question that was asked here before. I would say again that it really depends. And if I had to kind of like give a general solution, I would say, if you have a small project, like 1, 2, 3, 5 scripts that you want to kind of convert, and that's it, then will never be anything else, don't go for the library because it has some overhead. If you have a big solution out there, then you should. But I think it really depends on the library and how good is the Python port of that library and so on. Because sometimes the Python port is just like untyped API functions, and you might as well just call the REST API. So it really depends.
Okay, so...
We have one question?
So we'll take last two and then we can...
Okay, no problem.
So,
Yeah.
Oh, you have, okay.
What's the license of your library?
Oof. I don't know. I think MIT. I just went with the GitHub default. Am I in jail? I don't know. Excellent. I think it's just the whole library is like 300 lines of code. It's not such a big thing, and yeah, MIT. I don't know.
Any other question? We can take one last question. But we have one online too. Okay. Do you recommend to have many atomic scripts or a comprehensive one? The first is better to rerun in a case of errors. The latter is cleaner. How do you balance?
Well, those are like really questions like with a lot of responsibility. I would say just again, it depends. Depends, first of all, again, all these scripts, all these tools, it's important to remember that they are supposed to help you do your job better. If you feel comfortable, if it makes sense to have one script with a few CLI options, which we do sometimes, then have one script. If it's like completely separate two actions, one of them deploys something and the other one configures something completely different, I wouldn't use one script. I would use two separate scripts. Just like I would just look at it as the same stuff as just regular Python scripts. Just the bash part is just encapsulated. Just the same decision making you would do in deciding if to create another Python file or not, I would do the same thing here.
Thank you so much. So this is the end of the session, and I hope you guys enjoy it.